Hello, folks. Welcome to Rational Science, the only site on the internet that does physics at all. Everybody else does concepts or they simulate with particles. And one thing you cannot do is simulate any phenomenon of nature with particles. Invisible, phenomenon such as light, gravity. You cannot do it with particles, discrete particles. And so what mathematical physics has done over the years is what? Well, they've replaced particles essentially with abstract concepts. And they move these concepts around. Here we only move objects, things, and we say that the first rule of physics is that you must have an object, a thing. Otherwise, you cannot do physics. Anyways, today we have, we're going to be doing the unparticle, whatever that is. We're going to get into that. But we're going to start again with the etherists. I was swamped this week with a bunch of etherists who came and bitched about my last video on ether. They didn't like it too much, and here you'll see some of the problems that we find with the ether. And the main one is that they cannot illustrate the ether. There's not a single etherist on planet Earth, alive or dead, that has ever been able to illustrate the ether. They have no idea what they're talking about. And so here you have one fellow, and he says, "This is garbage channel." The fabric of space-time is the ether. It's always been there. It always will be there. Not going to watch your belief. Yeah, I guess once again, I think mind is a terrible thing to waste. And we have the etherists who are on ether, and then we have the etherists who are on crack. And what none of these folks can do is illustrate the ether. They cannot tell you what the ether is. They start already in the middle of the film, saying, this is what I can do with the ether. No. First you got to show us the ether, then you can do whatever you want with it. Okay? And so that's the issue. And so this is what it comes down to. They have no idea what the ether is. Some of them claim that they've never seen it, it's invisible, so that's why they have no idea what it is. But that's no excuse, because all you have to do, when you're talking about the ether, is illustrate what you have in your mind. Just pull it out of your brain somehow and put it out here so that we can all see what it is that you are talking about. Okay, we need to understand first, if you're going to use it as an object, as a thing, if you're going to be moving it around, please begin by telling us what it is. And the way you explain what it is by making a picture. That's the only way. You put a picture and say, this is the ether. Point to it, we're done. That's how easy it is. Very simple stuff. And no excuses allowed. Okay, so here we have one etherist. He came over and he says, you have no objects without ether being perturbed first. So he's saying there are no atoms, no tables, no trees, no nothing, right? No molecules, unless you have perturbation of the ether first. And so what he's saying is that objects are made of ether. But ether, he says, is a perturbation. It's motion. And so all objects are essentially made of vibrations. That's more or less what he's got in mind. He's saying that ether is not a thing, but it's a potential. Something that I guess eventually will come to be, and he calls that a perturbation. And not all etherists will agree with him. I'm just saying this is one fellow who says this is what the ether is to him, right? Now, doesn't mean that everybody will agree with him in the ether world, but this is what he's proposing, okay? And so he's saying that objects are made of potential perturbations or vibrations or whatever. It's just potential, right? I guess something that will eventually materialize. I guess that's what he's suggesting. Anyways, the problem there is that perturb is a verb. And, nouns are not equal to verbs. Nouns are not verbs. So to say that a noun is made of motion, out of verbs, I don't know. I think he's overdone it on the ether. That's what I think, he's done. And this is the big problem. They have these weird notions, and they think they're scientists because they've discovered something. They say the ether is correct. It's this perturbation, this vibration of whatever. We don't have the object that's vibrating. All we have is verb without a noun. But he says the nouns are all made out of verbs. That's essentially what they're saying. And so, for these fellows, we take them to the universal movie. What's a universal movie? It's a nice tool. It's a very handy tool for those who want to identify the objects in the universe. We stop the universe, right? We look at a single frame of the universe as if God took a snapshot at any given point in time. And that snapshot, which is, you can consider it a 3D snapshot, right? Shows every object in the universe, every atom, every molecule, everything that exists, right? And so we have now a snapshot of what's there. It fits all in a single frame of the film. And that's all the yellow stuff up there. All these concepts and every noun, everything in the universe fits into a single frame. You don't need to have two frames to know what a tree is, to illustrate a table or whatever. It doesn't matter. But when you look at a verb, you're looking at least two frames of the film. You can see the beige ones at the bottom there, the violet ones. And you can see that it occupies two frames, at least, of the film. Okay, that's what we're showing here. Nouns should be at the top, single frame, no need for two frames. The ones at the bottom, you need at least two frames. And so this fellow is saying that perturbation, that's what the verbs are at the bottom. He's saying that you need to see an object in two frames because two frames make up one object. And no, I don't know what convent he went to or monastery, but that's not true. Noun, we don't need to see any vibration. We don't need to see any motion whatsoever. In fact, nouns precede verbs. Objects precede motion. So, one day I had a friend of mine who, chemist, by the way, and he was taught in college that, this is what he told me. It just shocked the hell out of me because I'm saying this is not true. But this is what he was taught. He said that objects are made out of motion. They're made of motion. And he just said it candidly, like it's a matter of fact. That's what he was taught and that's what he believed. And it just blew me away because it's completely irrational to say that a table is made out of motion. And people say, well, the electron moves, the atoms vibrate, molecules are all jingling. No. When God takes, with his big camera up there, takes a snapshot, I don't care about whether the electron in the lab moves. I know that in that picture that God just took, the electron had better be a static object. And that's what we're talking about here. We're saying, take a snapshot, what do you see? And that should all fall in a single frame. We do not need two frames to know what a tree is, to know what an electron is, an atom or whatever. Or ether. Okay, so here we have what this individual has in mind. He's got this ether world, some kind of vibration of whatever. We don't know what that is. Maybe a rug, a piece of cloth. I don't know what that is, but that's more or less what they have in mind. And from this, he's going to build his particles, one's going to pop out of there, right? And so they're saying that the particle is made out of motion, and we just want to know what it is the material that makes up, the particle, okay? And this is what they cannot tell you. They cannot say what that material that's shaking there is. They start with motion and build objects with it instead of the other way around. Using objects to say, okay, now I have two frames of the film, now I build so-called motion with it, Objects build motion, not the other way around. Okay? So if we're going to do it rationally, that's the way you should do it. Objects, what is motion? Two or more locations of an object. So the object is here, then it's got a different location. Now you have motion, period. What's location? Set of distances from one object to all the others in the universe. We're done. That's how simple it is. All you need is just good definitions, scientific definitions, and then, you can give a rational presentation. Here's the 3D version of that, just in case. Okay, here we have the 3D ether. Okay, and we're going to put a particle in there. Okay, and there it is. It's moving around. This is what they have in mind. They're saying that the particle is essentially, vibration of the ether. And again, that's how they try to elude the requirement that they illustrate the ether first. Now, I illustrated something there, right? And you say, well, you illustrated the ether. Well, no, I illustrated motion of some kind of, lines there. That's all I did. Some line, we don't know what those lines are. Is that a net? Is that what it was, a fish net that was vibrating? So you got to identify the object first before you shake it. And all I can do is try to illustrate what these people are saying. But, at the same time, I have no right to put these things in their mouths other than the fact that they haven't taken the trouble to illustrate what they have in their minds. But it's up to them. They're supposed to tell me what the ether is according to what they have on the top of their heads. Okay, so that's the way it works. Okay, and here we have another fellow, and he's talking about the ether, and he says, fine, Tesla was wrong about the ether. That's Nikola Tesla. I guess he was Yugoslavian or whatever Yugoslavia was in those days, the end of the 19th century. Anyways, he says, light doesn't require a medium to travel. So he's saying, here we have this thing that comes to your eye, right? And he says it doesn't require a medium. In other words, it's not mediated by any object. Light is, according to him, some kind of spirit. I guess it's a phantom, an angel. I don't know. He's saying it doesn't need a medium. So whenever you shine a light, like from your laser to something to the wall, that red line that you can see, even sideways, because it really refracts through every atom of air or molecule of air in the environment, he's saying that that thing that you're seeing is not a thing. He's saying we don't need a medium. Okay, he says light travels fastest in the nearly perfect vacuum of space. That's not saying space doesn't have any properties. Well, I don't know what properties space can have. If space is nothing, space is not an object, doesn't have shape. So I'm not sure what properties he would assign to space. Invisibility, intangibility, maybe? I don't know. You could say those are properties. But other than that, I'm not sure what other properties he thinks space has. Certainly not those of objects. Space has very different properties than objects, the opposites. That knowledge made some really great practical applications. Well, that's talking about technology has nothing to do with science. Okay, science is about explaining. Technology is about making things. So whether it has practical applications or not is totally irrelevant. And then he says, this is the one that blows you away. The periodic table of elements is derived from the 4 classical elements: earth, water, fire, and air. This fellow is still stuck in the old Greek days. And he says, an akasha or akash, which means space or sky or ether in traditional Indian cosmology. And when you look up good old Tesla there, he says man's greatest achievement. He wrote this, I think, 1907, sometime at the beginning of the century, 20th century. And he says, long ago, man recognized that all perceptible matter comes from a primary substance of a tenuity beyond conception and filling all space, the akasa, or luminiferous ether, which is cited upon by the life-giving prana. Again, I guess he read a lot of Indian stuff, or creative force, calling into existence in never-ending cycles all things and phenomena. And he says the primary substance thrown into infinitesimal worlds of prodigious velocity becomes gross matter. In other words, here we have this prana or whatever nonsense, akasa. And what it does is it underlies all matter. That's what he's saying. It's the verb that turns into a noun, right? The force subsiding, the motion ceases and matter disappears, reverting to the primary substance. In other words, here you have objects, things that disappear, that disintegrate back into this akasa or prana or whatever they want to call it, and which is the ether, and then the ether turns back into objects. So they have this thing going back and forth, but good old Nick, he never told us what the ether is. Everybody in those days used the ether as the mediator of light, so they did propose a mediator. Light was the vibration of the ether, but they never told us what the ether is. No one had any idea. Why? Because the ether was everything. It's like all these particles that fill space and they vibrate, and so they never defined it or never illustrated the word ether, right? And okay, so you have this thing out there and they say it's the vibration of the ether, but first you have to tell me what the ether is. You can't just jump ahead and say it's a vibration of the ether, because I still don't understand what you mean by the word ether. Okay, that's the issue. And so another fellow says, I can say the ether is real. Oh, okay, great. We finally have someone who can tell us that the ether is real. I have done several experiments. Okay, here we have a guy who does experiments on intangible, invisible things. Okay, and he's going to do a bunch of experiments. Okay. Would be happy to send you the data. No, thank you. Don't send me the data. Send me the ether, in a little envelope, so I know what you're talking about. I've included a very simple explanation of how the ether forms and is sustainable. No, I don't want you to tell me how the ether forms. I want you to tell me what the ether is. Okay? If you can debunk what I show you, well, that's great. No, there's no need to debunking. All you need to do is very straightforward. You just send the ether, or illustrate it, or point to a website that has the ether illustrated so that we know what you're talking about, okay? Yet I highly doubt that you can. My evidence is used to convince, to persuade, right? And that's why he wants to use evidence. He said, I'm going to persuade, I'm going to convince you. I don't want to be convinced. I want to understand, okay? Supports the existence of God Almighty and heaven. So good old ether, I guess, is God, and God is ether. I have no idea what he's got in through his mind, this poor fellow. Yeah, all he's got to do, all these people have to do the same thing. Just illustrate the ether and we're done. Look how simple it is. All you have to do, all these years, Tesla and, Faraday, even all the way to Newton, all these people talked about the ether. No one ever illustrated the ether and told you what it is. And nobody ever realized that that's what you had to do. And they might say, well, I can't see it. I don't know. I've never seen it. I don't know what it looks like. Hey, this is what you have in your head. You have to pull out of your brain, out here, what you say or what you think the ether looks like. Okay? Because you're going to be using that word ether. You're going to be using this thingy. You have to tell the crowd what you have in the back of your mind. Bring it out here so we can all see it, we can all touch it, bring it to the conference, make a mock-up, and we can all touch the ether. Tell us what the ether is. Illustrate it. And they don't understand this. They say, well, I don't know what the ether looks like. I've never seen it. No, it's what you have in your head. That's what you got to put out here. We don't care what the ether is for real. We care about what you think the ether is so that we can follow your presentation. And so here it is, fellow. You have to define real also, right? And because we don't know what you mean by real, and that's a very important word in physics, because physics is the science of real, of existence, right? And in science, real means physical presence. That's what it means. If that's not what it means to you, then we require that you define the word real in the alternative. If ether is real, then you shouldn't have any problem to illustrate it according to that definition, because physical is an object, and an object is that which has shape. Therefore, you have no reason to avoid not illustrating the ether. Okay? And experiments are not part of science, so don't worry about doing experiments. We don't care about experiments. We care about what you understood after doing your experiments. We care about your explanations. That's what you got to come forward with. And science has no use for evidence. Again, evidence is what is used to persuade, to convince, to convert. It's got to do with belief. You're trying to prove to a jury, and we call all that, we dismiss all that as religion. Okay, all that has to do with religion. Has nothing to do with science. Science we need to explain, not believe. And whether God exists is an assumption, So he says, my evidence supports the existence of God. You don't need evidence. You don't need to support anything. You need to define the word exist so that we know what you mean by the word exists, and then we'll know what you mean when you say that God exists or that heaven exists or whatever. And according to science, God exists means, it's an object with location. That's what you mean when you say God exists. If that's not what it means, what God exists means to you, no problem. You define the word exists for us, and then from there we'll find out if God exists by definition, right? Very simple stuff. Okay, here's another fellow, and he also insists on the ether. He says, Einstein came to the rescue and saved the Copernican model. All that was needed was to jettison the widely accepted theory of luminiferous ether. Since abandoning the Copernican system prima facie would be anathema, and abhorrence of the ether was adopted by the dominant faction and became the new orthodoxy. In other words, they displaced the ether, right? And they came with this stuff called space-time, which was preached with the greatest conviction and zeal by all correct-thinking physicists, eventually, right, starting around 1920. Leaving no room, no chairs, no grant money, no publication, no awards, and no respect according to wrong-thinking non-believers. Okay, yeah, that's more or less what happened. Evidence of the heretical purging persists to this day and is legible in the sneering language found in all undergraduate physics texts on mechanics, and especially is seen in the presentations of science popularizers intended for laypersons, which invariably ooze with hubris, pride, and arrogance, as they pretend that science knows, and by inference, they know what science cannot know. Yeah, that's true. What they've done is harp on evidence, on proof, on belief. As for you parishioners, you're kneeling in the Church of Scientism and hearing a sermon from one of its priests. If you reject communion or refuse to repeat its creed, then you will suffer the fate of all non-believers. First let's take care of Einstein here. He says, came to the rescue and saved the Copernican model by getting rid of the luminiferous ether. And here we have the record. Here is Einstein, at least two pieces of evidence, if he's talking about evidence. He wrote a pamphlet, a booklet there, and he says the following: Einstein ether theory is a modified theory of gravity that breaks Lorentz symmetry by introducing what? A dynamical vector field called the ether. And in 1920, in a talk that he gave at the University of Leiden, he says the following. Einstein said this. He says, we may say that according to the general theory of relativity, space is endowed with physical qualities. Just like this other fellow said a minute ago. And he's saying it's physical qualities. In this sense, therefore, there exists an ether. According to the general theory of relativity, space without ether is unthinkable. So the good old Einstein, did he believe in the ether? Well, at least he did until 1920. Whether he changed his mind later on in life, I don't know. But he always talked about the ether and space-time, which is his bread and butter of the theory of general relativity, is an ether theory. He's saying, look, there's all these points in space-time, all these dots out there. That's how Stephen Hawking defined it. What is an event? A point in space-time, and space-time is made of events, of points in space-time. So, yeah, we're talking about a whole bunch of dots out there, a bunch of particles, I guess. That's what they're referring to. We're talking about physics, and that was the theory. The theory is a particle theory. That is the ether, so nothing changed. The only thing that people sometimes debate is whether the ether is static or dynamic, whether it's moving or it's standing still. And objects such as the Earth are moving through a static field or through a dynamic field. That's the only issue. But the ether has always been a bunch of particles. fluid, as they call it. What is a fluid? Made out of particles. I mean, that's what normal fluids are made of. If you think that a fluid is made out of something else, no problem. Illustrate it. Tell us what you mean by fluid. You know, you can't just say it's a fluid. You haven't said anything. Okay? So far, you have a sandbox, static ether. You want to move it, that's something else. Okay? Before you move it, you got to illustrate the ether. Okay, some of that, and again, you can see these are all particle people. The fellow says the following: it's a misconception to assume that mass bends empty space-time and the path of a light ray. It's the gravitation from mass that changes the density of the medium through which the light propagation is happening. Okay? The direction of light is altered due to the varying density gradient of that medium. Okay? So perhaps that is what is near stars and around galaxies. Matter, not empty space. Okay? So he's saying that we have all this matter around every object, celestial object, such as stars and planets and galaxy. We have all this matter running around, right? It's not empty space. There is no empty space according to him. In fact, if you look at astronomy literature, you will find that what? Hydrogen is all over the universe around galaxies and stars. No space-time required. So what this gentleman has in the back of his mind is that the entire universe is filled with hydrogen. Okay? So we have all these hydrogen atoms everywhere. That's the ether, right? Particles everywhere. And they're shaking, moving, whatever they're doing. We don't care. Sometimes they're static. Sometimes they're moving. No problem. You can choose whichever you want. This is a complete misconception of what we have out there in the universe. This fellow doesn't understand how our universe is built. Certainly the universe is not made of, all the, like, for example, between two galaxies, it's not filled with hydrogen atoms. He doesn't understand that. He thinks that hydrogen is everywhere between the galaxies, so instead of empty space, what you have is hydrogen atoms, meaning matter. And he says because the astronomers have found that around every galaxy, every sun, every star, every planet, what you have is hydrogen. And so he's saying because they found it around there, it's everywhere. But see, everywhere is not the same thing as around the star. You can find hydrogen around the star, yeah. But then at some point, that dwindles and there is no more hydrogen at some point. To say that between any two stars you have, the whole field, the whole space filled with hydrogen, no, that's a total misconception. And here, let's educate this fellow a little bit so he doesn't commit that error again. These are the levels of vacuum, okay, that we have out there. We have atmospheric vacuum, vacuum or pressure here on Earth, right? And then you have values for each one. You have what is known low or roughing vacuum, which is a mechanical pump, can take it down to what is known as a micron or 10 to the minus 3 torr. And then you have the medium vacuum, takes it down to the minus 5 range, thereabouts. Then you have a high vacuum. I work with high vacuum. I worked at the minus 7 level. And then you have extreme high, ultra high vacuum, which is, in the 12, 13 range. And there you have two different sources that I put there. And one source puts, just looking at the low through ultra high vacuum, you see the powers there. You have the 22, 19, 16, and 12 under the one group, and the other fellow puts 19, 16, 13, 9, and 4. And you can see some of the numbers match. So more or less, this is what is out there in the vacuum world. You have these values, and you can see how the amount of particles per cubic centimeter or per cubic meter drops as you get to high vac. Okay, and that's the point that I'm trying to make here. So when you go out there between stars, you get into the minus 12 range, minus 11, minus 12 range. It's said that on the moon you have a minus 11 torr range. That's what was measured for those of you who believe that we went to the moon, right? And they measured it in space also on the trip to the moon. They had a device there, and they were able to measure as best as they could, with a moving rocket here, right, a probe, whatever, and they were able to measure the vacuum of space, and from that they inferred or measured, right, as closely as possible, that the solar wind, they talk about solar wind, everybody thinks it's a wind like, air here on Earth. No, it ain't. It's minus 12 torr. It's even less dense than on the moon, an order less dense. And so that's the vacuum out there. You either have minus 11, minus 12, and what you're talking about, very few particles per centimeter cube. And unless you understand that, you're going to make errors like the electric universe makes, that they have this connection from star to star, and they say electricity flows from star to star. Absolutely not. It's impossible. It's impossible because there is no matter in between two stars. You have high vacuum, you have one particle over here, the other one separated. How does from this particle, how does electricity flow to that particle? If the flow of particles is the movement of an electron from atom to atom. Now you can do that in a vacuum chamber as long as you have first high vacuum and then introduce, say, an inert gas such as argon, right? Then now you filled the chamber back with atoms, with molecules. Now you can have electricity. But if you take all the stuff out, if you get to minus 7 range like we used to work with, sometimes you get arcing, which is, a glitch, but you cannot have a constant current on minus 7 range. And out there you have minus 11, minus 12, forget it. You're never going to get electricity, as the electric universe, tells the crowds. They say that some of the features in Mars were made by electric shocks, thunderbolts. No way, it's impossible. There's not enough matter around Mars to create a thunderbolt. Okay? You don't have thunderbolts on Mars because there is no matter to do electricity with. You need matter, atoms, molecules, to have electricity. And these people don't understand that. They think they can do electricity just by flowing beads, electron beads, from one atom over there to one atom over there. No way, you can't do that. These people don't know the basics of vacuum and of electricity. That's the whole issue. Okay, here's a fellow who talked about the Harvard Tower experiment. He said, GPS sends a modulated signal from satellite to ground. The time at which it reaches the ground can be measured, okay? Time received is multiplied by the speed of light to get the distance, okay? If the frequency or energy increased in transit during that time, the phase reversals would be wrong and the major distance would be short, okay? And he says the frequency cannot be changing as it falls. Did you actually, the first part up to there was a quote that he quoted someone. Now he comes in here and he says, did you actually conflate distance for length when talking about a rope? Yes, you did. Okay, I have no idea what he's talking about, okay, because I wasn't talking about distance or length, okay? It had nothing to do with this at all. And so I want to clarify what I was saying, at least. I don't care what he understood, but I'm going to say what I really mean, what my theory is, what I'm proposing, okay? And I'm saying that as the ropes come out of the earth, okay, they tend to get longer. By longer, it doesn't mean that, very long. It means that, if you got a high frequency rope, meaning very short lengths and many links, as that goes outwards, right, eventually the links get longer and you have fewer links. That's all I'm saying. We don't care about the amounts because we don't care about amounts. All we're saying is it does tend to get in that direction. And here, let me show you here. Here you have light coming out of the earth, and the earth goes in every direction. The question is, what is that light, those rays that are coming out, what is that mediated by? Okay, that's the issue. And so we simulate it with ropes. Here it is. Okay, so we're saying that what we have is torsions along each one of those ropes, and torsion travels in both directions. Okay, so we have ropes. We're saying that light is mediated by a rope-like entity. So there is a mediator for light. And we're saying it looks more or less like that, like a pair of twined threads, like DNA. That's what it is. Okay? And so the issue is the following. When you have a satellite out there, like GPS or whatever, okay, some of the ropes end up in the atoms that make up the satellite. Okay? And some of them continue because they don't stop at that atom. Some of them belong to atoms that are on the moon and another star, another galaxy. So you have all these ropes, and most of them are superimposed. They're on the same axis, okay? And so you have to understand that, because if you take a cross section, like if you're going to measure frequency, meaning you're going to measure a cross section somewhere along an axis, you're going to have many, many, many gazillions of ropes on that same axis. And that means some of them are going to have short lengths, and some of them are going to have longer lengths. In other words, you're going to have different frequencies and different wavelengths for any cross section, because every atom in the universe is connected to every other atom in the universe. Okay, so we have to understand that on a given axis, we're not going to get a single rope. We're going to get gazillions of ropes. They're all going to have different frequencies. Okay, so that's you have to put that in the back of your mind, because that's important. Okay, so whenever they take a reading, cross-sectional reading, at any point and say, what's the frequency here? The frequency is so much. Okay, we don't care, because what they're doing is taking a reading, a cross-section of many, many, many ropes that pass through that point. You can't take a measurement of one rope between only two atoms. Okay, no matter what. When you have two atoms, you have gazillions of ropes going through those two atoms. Only one rope connects this atom to that atom, right? But there are many ropes crisscrossing the entire universe. They're going right through there. Okay, so that's important to understand. So what happens? Let's say you have a flashlight, okay, and you're going to point it at a wall. Okay, so you have this flashlight, and you can see that there are atoms that are originating in the bulb of the flashlight, and they end at the wall. Okay, so you have many atoms there, right, that just are connected from the atom in the flashlight to an atom on a brick on a wall, for example, right? But as you can see, there are other atoms that are coming from behind the flashlight, going right through the flashlight, right through the wall, and going to other atoms in the universe. Okay? We cannot isolate a single one of those ropes and say, I'm going to read what the frequency is on one rope only. What you're always going to get is an average, right? But the main one will be the one that's closest to your scenario. Okay, so as soon as you turn the flashlight on, okay, and you point it at the wall, you get this situation where suddenly, the high frequency that you suddenly put in your region, that takes precedence. Okay, so you can more or less get a reading of your frequency there, but again, you're reading many ropes. You're reading the torsion on many ropes, you're reading the wavelength on many ropes, the length, right? But you still have all these other atoms that are connected from behind the flashlight, right through the flashlight, to atoms on the wall and beyond. So you have all these things going in that same region. And what you're going to be doing, whether you like it or not, is taking an average of that. Okay, and so for this fellow to be so sure that he measured a given frequency, he's got to factor this scenario in mind. Okay, that's all I can tell him. You cannot really say for sure what the frequency is, because you cannot measure the frequency, wavelength, length of just one rope from one atom to another. We don't have that capability yet. Okay, we're too far away from that. Okay, another fellow says something about the Harvard Tower experiment, and here it is. The pound replica experiments were done at Jefferson Labs. Okay, the elevation on the ground is 3 meters above sea level. The temperature would be 14 degrees. Okay, the gamma rays traveled through a mylar bag filled with helium. Okay, so he's saying it wasn't completely isolated. They had something there. Okay, which is a refractive medium, meaning that we're going to disperse that beam. That's more or less what he's saying here. to minimize scattering of the gamma rays, but you're still going to have some scattering, right? Poundorek found that a large source of systematic error resulted from temperature variations due to lattice vibrations. Okay, so we have all these interference or these obstacles or these influences in our experiment, right? A mere 1 degree difference in temperature between emitter and absorber caused a shift about equal to the predicted effect of gravitational time dilation. Okay, I'm not going to criticize what he said. He's got a good point there. Okay, not that I agree with it, but he's got a good point. Okay, the question is, how isolated was the experiment when they did it? But more important than that, you know, the mathematicians, they pride themselves in talking about repeatability, and no one has ever. I looked it up. I can't find it. I mean, if you can find it, please send it to me. But I can't find that anyone has ever repeated the Harvard Tower experiment anywhere on the planet. It doesn't have to be the exact Harvard Tower. You know, you don't have to go to Harvard to do it. You can do it anywhere. And once you have the setup, you say, okay, I'm going to repeat the setup, see if I get the same result. And I can't find anyone who repeated that specific experiment. You know, one on the bottom, the other guy on the top, and sending a beam in both directions, first from the top down and the next from the bottom up. And so I have not seen a repeat of the Harvard Tower experiment. It's like everybody just accepted it and said, okay, it's blessed. So just keep that in mind as well, and that's my only criticism there. One fellow says, I guess he confused atheists with etherists, but still we'll address what he said. Atheists don't propose any theory, so I don't know if he put that under the ether video. But so let's address atheism just in case, so we don't put words in his mouth. Atheism is the religion of mathematical, theoretical physicists. Okay, that's what it is. Atheism is incorrect science. It's irrational science. That's what atheism is. Why? Because they talk about belief. And what do atheists propose? Well, they propose the same thing as all mathematical physicists or theoretical physicists. They propose what quantum mechanics, special and general relativity, and string theory propose, and that is that you have to prove, that you have to believe, you have to present evidence and have knowledge. And none of that has to do with science. In science, we do not have knowledge, we do not use evidence, we do not propose to or purport to influence people's way of thinking other than through understanding, you know, explanation. I explain, you understand, we're done with physics or science. But if you now introduce evidence and try to convince someone, now you're persuading, now you're doing religion. And we have to separate those two. So all these Bible thumpers of general relativity and quantum mechanics, they're not doing science. What they're doing is persuading. That's religion. And being that the case, you know, they haven't done anything different than religion has done all these centuries. And here, let me synthesize that for you in a little video. And here it goes. Just watch it. Okay, here it goes. What is a theist? A guy who believes in that God exists. What is an atheist? Well, it's someone who doesn't believe or disbelieves, or however they want to word it, that God does not exist. Okay, an agnostic guy who doesn't know whether God exists or not. And we take all of these fellows and put them in the trash can. They're all under religion. This is all religion. And that's why all these people, you know, they haven't been able to figure out anything in science, because they're using evidence and that kind of thing. They're talking about belief. And here, this is what rational explanations are all about. It's objective, it's explanations. That's what science is about. Okay? So, make sure you are not a mathematical physicist, because if you are a religious individual. Your religion is atheism, and atheism is founded on belief. They call it disbelief, they call it not believe, unbelieve. They use all these terms, and they run around in circles. Atheism has to do with belief only. belief in God or disbelief in God or whatever you want to call it. And the issue there is very simple. We do not do belief in science. So all these people are doing religion. And they've been running around in circles, chasing their tails around, arguing in circles for centuries. Okay, final issue of all says, a thoughtful, contrived, systematically executed, extremely well-funded, and relentlessly persistent campaign of denigration, mockery, fear-mongering, and false reporting of assemblages of anecdotal evidence directed against the established, now deemed alternative systems was implemented. He's saying that when the mathematicians at the beginning or first quarter of the 20th century came with space-time and quantum mechanics, they brushed aside everything from classical mechanics, essentially. And the situation is not unlike that of relatively new orthodoxy or allopathy. The business of science prevails over science itself. He's saying there's a lot of, hullabaloo. They tend to say that they've discovered something that it's new, they have this new theory, it's a paradigm shift, etc., etc. And he's saying it's all business, really, ultimately. And so what do I have to say about that? Well, I'm certainly one person who has a little bit of experience with that. When I came to some of these websites, or really forums, where you had all these college guys, and I started telling them, hey, guys, I went in there like mild-mannered Clark Kent, I thought I was very naive and with respect to all these people. And I said, look, I have a new theory, I want to share it with you, blah, blah, blah. Boy, did I get a lot of rotten eggs thrown in my face. I couldn't believe the environment out there. I thought science was, normal or just an exchange of ideas, and that's not the way it works. They use a lot of ridicule, they do censorship, and yes, it is a business, and people are concerned about their careers, and so I don't think that's avoidable. That you cannot. I don't think you can avoid that. And here we have a good example. This was thrown at me once, and so I always like to put this up there, and that's from Juanito Baez, fellow that is in California, and he thinks of himself as a big shot. He's the guy who created the crackpot index. They used this against me in a couple of those forums, and that's how I found out about it. And here you have some example. He says 10 points for each claim that quantum mechanics is fundamentally misguided. 10 points for arguing that while current well-established theory predicts phenomena correctly, it doesn't explain why they occur or fails to provide a mechanism. Absolutely. And so he just says you get 10 points off for requesting, for demanding an explanation, a mechanism, a why. And he says, hey, you get 10 points off for just asking. In other words, he's not going to give you a why. He's not going to give you an explanation, a mechanism. He has no clue whatsoever. Why? Because he's a mathematician. That's all he is. And then he says 10 points for each claim that special or general relativity are fundamentally misguided. And again, I think if I were the U.S. government, I would deport Juanito back to Mexico, where his mamacita came from, where she was picking strawberries or beans out there in the fields. Yeah, this does not understand what science is about, and that's why they use ridicule. And so I don't feel bad when I ridicule them. Actually, I don't ridicule them. I treat them with the respect that they deserve. That's the way I put it. But it doesn't stop with the mathematicians of today. Here, let me show you something else. These were the different schools of thought, right? Let me make this better this way. These were different schools of thought from the Greeks, right? And what I want you to understand about this is they came from different cities and they formed in different towns, etc. And all these different schools would ridicule the other schools. Like, look what this guy believes in. They would ridicule one another. And so ridicule has been with man since day one, okay, in so-called science. And so I was very naive when I came out. I thought, that there was a peaceful environment there where you can present your theories and so on. That's not the case. So anyone who goes in there and starts getting all excited because someone insulted them or ridiculed them or censored them should come to up to speed. You know that the environment has always been a so-called scientific or exchange of ideas environment has always been cutthroat. It's a dog-eat-dog world, you know, out there. And so for people to expect that a guy who you're challenging, his ideas, his God, his Jesus Christ, his space-time, whatever you're challenging, you better be ready to receive a handful, you know, of rotten tomatoes in your face. Okay, and there's no way to avoid it. That's always been the environment. He who has not understood that, oh man, he's a babe in the woods. He's a little lamb, and the environment out there is very nasty. Be ready for it. You know, they will not allow you to publish, censorship. They will ridicule you if you go to a forum, and they will insult you, and they will do everything they can. So just be ready. That's the environment. That's a scientific environment. It's always been like that. Okay. Okay, let's move on to our main course for the day, and that is the unparticle. What in the world? What in the world is an unparticle? I barely understood particle because under quantum mechanics, particle ain't a particle. Particle means a number followed by a unit, you know, and they vibrate this number. They do all kinds of things. They say it's a field, vibration of a field. That's what a particle is. And field is a concept, bunch of numbers. So we never have anything solid to, you know, put our munch to really chew on. And so, this is unbelievable. They invented new term, and this is a term you have to become familiarized with. That's what I'm going to be arguing today, and it's called unparticle. But let me show you something first. I can hear a brief introduction, and that is this is a article that came out there. It says it was reposted. It's an old article, but it was reposted. It says scientists find galaxy supercluster as massive as 26 quadrillion suns. And the question is this what science is about? Saying, hey, we found a lot of particles out there. We found a lot of stars. We found a lot of planets. We found a lot of galaxies. You know, is this what science is about? Talking about the many things that they see out there and just putting it on a little picture there or even a drawing and saying, hey, look at what we found. We found a lot of stars. You know, and so what is this science? Just posting a picture of a bunch of stars? And this has a lot to do with the subject matter of today of the unparticle. Okay, the unparticle. Let's start at the beginning, and the beginning is the Big Bang. Here's the Big Bang, okay? And they had this explosion, supposedly 14 billion or so billion years ago, okay? The famous Big Bang, okay? And that's how the universe started. Where did it start? Well, it was a singularity there. That first dot that you see there supposedly is a singularity. What is a singularity? Well, we have no idea because it's zero-dimensional, right? No volume, therefore no matter, no nothing in there. But suddenly this nothingness exploded. And that's the world we have today. And some people even challenge and say, well, it wasn't really an explosion. It wasn't an expansion. I have no idea how they visualize this because what they illustrate is just exactly that. An explosion, an expansion of something. It's like a hand grenade exploding. That's what you're staring at, okay? And so what does this turn into? Well, here you have it, more or less, okay? Turns into that glass of wine or a glass of beer, right? That is sideways, okay? There it is. And so the explosion leads to this, and that was took 13.8 or 14 billion, rounding off, years ago. Okay, so that's what the explosion of the singularity leads to. Okay, and from that they come up and they tell you, okay, we can tell you what happened throughout this time, and here's like the history of the universe, of how different things were created along this this history, right? At some point you got the first particles and the nuclei, first light, stars, etc. So I guess there was no light when you had this explosion. Okay, that's interesting. That means you had just dark stuff being exploding from there, and it turned into light sometime later. And then you get the first stars, galaxies, and so on, right? And dark energy, which we're going to talk about today, is right there next to the last, just before today. So dark energy is really a new phenomenon, relatively, right? I mean, it happened relatively recently. Okay, so this is what the mathematical physicist or physics proposes. That's what a universe was all about. There was a moment of creation, no God involved. That's not what the religious folks say. They say, hey, you're missing God. God made the singularity, then everything took off. So what the religious folk have done is they've taken God and put it into the general relativity history of the universe, and say God was first and then the singularity, and the other guy started at the singularity without God. That's the only difference. Otherwise, they both believe in creation. And the only thing you really have to ask to either group is, don't tell me that God created it. Don't tell me that the singularity created itself or self-exploded or whatever. Tell me what the mechanism is, okay? Which is what good old Juanito Baez did not answer, right? He's saying that's not part of science and not part of physics. Yeah, what they want to do is a bunch of, they want to do a bunch of numbers, equations, and they want to get by with that. And no, physics is about the explanations, the mechanism, exactly what he's avoiding. Okay, so this is what we have here. We have this dark energy, okay, and it's pushing everything outwards. You can think of the black stuff there as the dark energy. We can't see it, that's why it's dark, and it's pushing all the visible stuff outwards, okay? And you get to this situation, okay, where you have, all the particles are going outwards, but then the question is, what is it, all this moving up against? Assuming, I put it as a circle because I'm assuming if it expanded from or exploded from ground zero, it's got to be circular or spherical, more or less, as it moves outwards. And the only question I've got is, what is it pushing up against? What is it, what's on the outside of this expanding bubble, right? Because, I think it's a valid question, because what you see, the dark stuff there inside the circle, is space that is populated or filled with dark energy. And so what's the black stuff on the outside if space is on the inside? And again, they say one of the answers you get is that it's an unscientific question. Okay, it's unscientific. Why? Because they say we have no way of testing the hypothesis. They put in words of that nature. And here, no testing is required. This is a conceptual issue, completely conceptual issue. You have to tell me what's on the outside if your theory is about to work. If you're going to say, hey, I've got a theory. What's your theory? My theory is that there was this explosion and all matter is expanding, all matter and space, right, is expanding and blowing up. Okay, what's on the outside of that bubble? It's a valid question. And they say it's invalid because they can't answer it. That's the issue. In fact, they can't even answer how the singularity, what's outside the singularity, especially if the singularity is zero-dimensional, and no volume, no shape, no size, no radius, no diameter, no nothing, no matter. So, yeah, I don't know if you can put anything outside of what is already nothing. What are you going to put? Nothing outside of nothing? So this is where we're at. That's the state of the art in physics. Okay, so this is what they're saying. They're saying that dark energy fills the space all around galaxy, meaning around every star and every every planet or asteroid or whatever. And this is a problem because either you put it on the outside, like they do with dark matter, and if you put it on the inside, we have a problem because then we should be blowing up. and dark matter should be pulling it inwards. And they always put the dark matter on the outside, on the periphery of a galaxy. And as far as dark energy, no one has specified that where it's at. They like to look at the big picture and say, look, dark energy pushes all these galaxies apart, but they don't tell you whether dark energy is between the Earth and the Moon, at this level. Is it between you and me? Do we have dark energy pushing us apart because it's blowing up, it's expanding, right? It's pushing everything apart. Are we getting separated because dark energy is between us too? And so these are valid questions, and they never deal with those questions. They want to do math. That's all they want to do, equations. And they're looking for ghosts and spirits somewhere out there that are pushing the galaxies apart. Okay, and so here you see it. Again, this is the balloon analogy. And what's the problem with this? The problem is that it's going to push, see those curlicues there? Well, those are light. That's light. And so they're saying as the universe expands, as space expands, as dark energy compels everything to expand, the wavelengths become longer and longer and longer. That's the argument. Okay? And so this is kind of strange because, that would mean that, I guess, light would have a different speed. And they say no, and this is important for the argument of the unparticle, because it's a scalar thing. You can make it bigger, nothing changes. The speed remains the same. Okay? And so this is interesting because they're saying, hey, even if the universe expands and it stretches the wavelength of light, we wouldn't notice. We would measure the same speed because, the fact that it becomes bigger just makes everything become bigger. I guess you're getting bigger as well. I don't know if you're bloating up like a toad, like a smoking toad. So, keep those issues in mind, okay? Okay, here we have dark matter and dark energy, okay? We have the percentages. Dark energy, they claim, maybe it's 73% of what's out there. Dark matter is maybe 23%. And the luminous stuff, the stuff we can really see, is only 0.4%. Okay, so we have a lot of matter there that we cannot see, which they haven't identified really. They have dark matter, they have dark energy. And some people turn this around and say, hey, this is really a measure of how much we really know about the universe. And yeah, I would say that's really the case for mathematical physics. I think that what they know is really 0.4%. That's all they really know. And all the other stuff they don't know anything about. And so they're inventing all these terms, okay, dark energy, dark matter, and what have you, because they have no way of explaining. They don't have the why. They have no mechanisms for how this universe works. So they have to put in these terms. They say, oh, it's dark energy. Well, what is dark energy? Well, we don't know. We're looking for it. Okay, so it's a measure of their ignorance. That's all it is. And so there was an article, and that's what got me into the subject matter today. There was an article recently published, and this is what they propose. They propose the unparticle. They say it's not dark energy. It's the unparticle. Okay, so what the hell is the unparticle? So we have unparticle physics is a speculative theory that conjectures a form of matter that cannot be explained in terms of particles using the standard model of particle physics because its components are scale invariant. Okay, scale invariant, what the hell is that? So let's look at that real quickly. Okay, here it is. Scale invariant means the following. It says is a feature of objects or laws that do not change if scales of length, energy, and other variables are multiplied by a common factor and thus represent a universality. The technical term for this transformation is dilatation or dilation, either one. Okay, so that's what they're talking about. They're saying something that doesn't change in scales. And that's more or less what I said earlier about light being stretched. You wouldn't notice because everything remains the same regardless of how big you make it. Okay, so that's more or less what scale invariance means. And that's like, this continues. I think this is out of the Wikipedia. All particles exist in states that may be characterized by a certain energy, momentum, and mass, okay? In most of the standard model of particle physics, particles of the same type cannot exist in another state with all these properties scaled up or down by a common factor. Electrons, for example, always have the same mass regardless of their energy or momentum. But this is not always the case. Massless particles, such as photons, can exist where their properties scaled equally. Okay, so you can make a massless particle bigger, no problem, because it's got no mass, so don't worry about mass. But this immunity to scaling is called scale invariance. The idea of unparticles comes from conjecturing that there may be stuff that does not necessarily have zero mass, but is still scale invariant, with the same physics regardless of a change of length or equivalently energy. This stuff is unlike particles and described as unparticle. The unparticle stuff is equivalent to particles with continuous spectrum of mass. So this whole thing was invented by a fellow to explain particles that have some amount of mass. You know, they're exactly or more or less like photons. Remember, the photon is allegedly massless. It's when it's standing still. It's got no mass, they say. It only has mass or energy or whatever they fill it with when it moves. And here we have something that when it's standing still, it still has a tiny little bit of mass, but it doesn't interact well with things, with matter, with the stuff that does exist. And that's how they get around it. They say, hey, we haven't detected it because it interacts very weakly with matter. So they have all these things like neutrinos, they all interact weakly with matter, meaning that they invented a term that they needed in their equation, but they can't find it, and they say, we can't find it because it interacts weakly with matter, because either it has very little mass or it's scale invariant or who knows what. They have some excuse for why they can't detect it. And so they try to detect these particles through experiments, right? And they say that particle's there because we need it in the equation. But let's find out how we can detect it now. And yeah, they're talking about ghosts and goblins and who knows what. And the most famous one of those, are the virtual particles. They look more or less like this. They pop in and out of the vacuum. Okay, and so they say these particles form part of the vacuum. In other words, they are really part of this dark energy, right? Virtual particles, they all mean the same thing, really. These are ad hoc things that they put in there because they want to be able to make the equations come out right. And they say, well, something happened here that we weren't able to see. There was a difference in the measurement, and so what do we put in there? Well, let's put a spirit in there, and that spirit is called dark energy or virtual particles or unparticles or whatever they have out there. Okay, and so, yeah, so the issue is that they're putting all these new words and then dark energy being replaced now by the unparticle, okay? And that's what the unparticle looks like. If a particle looks like something that has shape, the unparticle, I guess, looks completely dark, nothingness. Particles that don't have shape, maybe they have a little bit of mass because they're scale invariant, who knows what. They invent all this nonsense because they need to plug holes in their theories. It's all ad hoc. None of it has any reality whatsoever. And that's why people have lost interest in so-called physics, what the mathematical physicists call physics. Because it's just boring. They just invent new terms and then they say they proved it. And here you have another fellow who proposes something else other than unparticles. And he's got another explanation for dark energy. And he says the following. He says, the universe is twice as old as anyone thought. Okay? And he goes in there and says the universe might be almost twice as old as we believed, being 26.7 billion years instead of, I guess, the 13.8 or whatever, 14.8, right? And he wrote this some time ago, so it was 13.7 at the time. He raised that to 14.8 or 13.8, I guess. It says the new theory suggests that the universe might also be made completely of different material from what scientists previously believed. And what is this guy proposing? He says, rather than requiring mysterious unseen dark matter to make up everything, it's actually to do with forces of nature decreasing over time and light losing energy. Okay, and this is what he's proposing. He's saying that in standard cosmology, the accelerated expansion of the universe is said to be caused by dark energy, but is in fact due to what? The weakening forces of nature as it expands, not due to dark energy. Okay, so we have some people who propose that, I guess, energy gets tired, as it expands. So it's not that there's dark energy there, but there's some kind of matter that weakens as it expands. The other guys propose unparticles, say it's not dark energy, which has a specific definition for mathematical physicists, than what these other mathematical physicists are proposing. And so they say, look, the unparticles, they can solve our problem. We don't have to do all that dark energy stuff. It's just the unparticle, which has a little bit of mass, and they play around with the numbers and try to show that it's dark. It's the unparticle that really replaces dark energy as the fuel that expands, that pushes outwards all the galaxies and all that stuff they're measuring out there. What's the issue? The issue is that all these people write a paper, and they claim at the end of it, saying that, someday, maybe 10 years down the road, when we have more technology, more proof, more tests, more experiments, someone will corroborate what we just said 10 years earlier. And so they all get a Nobel. The guy says, hey, I was the first one to propose the unparticle. And he says, someone will prove it in the future. So the guy in the future has nothing to do at his desk. He says, oh, what do I do? How do I get a Nobel? How do I get my paper published? So he publishes a nonsense poppycock paper on unparticles or tired energy or whatever. And he proves mathematically that is the case. And he proved what the guy did 10 years earlier, and they both get a Nobel. The guy who came up with it first and the guy who proved it. And so they both share in the Nobel Prize. And that's how this whole thing works. The black holes were proven like that. One guy proposed it sometime in the past. Then a few of the mathematical physicists ran with it. And at some point they proved it. They said, we saw it, we photographed it, and now we corroborated it. And then the guy who came up with it, he gets a Nobel if he's still alive. And the other guy who proved it for sure gets a Nobel. And that's the way it works. But their names get put in lights, and that's what's important. Okay, so here's the space-time field. That's what this dark energy is all about, the so-called unparticles. How do these particles come into existence? And this is how they visualize them, more or less like the ether is. In fact, no different whatsoever. So space-time or general relativity is an ether theory. There's no difference between ether and what's the general relativity proposes. And here it is. Here you have your space-time. This is two-dimensional. You could say 3D vision, 3D vision superimposed on a 2D platform or whatever you want to say there. And that's your space-time. That's the starting point. Suddenly we're going to put a particle in there because what you're staring at is a field. What they call a field. And what is a field? Well, it's a bunch of those lines. And one of those lines, is that a canvas? Is that a trampoline? Is that a fishnet? No, what you're staring at is what we covered last week, and that is number lines. Okay, they're not even dimensions or coordinates or vectors. They are number lines. What you're staring at is each one of those lines is direction and magnitude. And what they're doing with that is they're shaping the number line itself. Okay, and so this is the aggregate of all those gives you this space-time thingy. Okay, that's what they're going to use as a platform to explain gravity, or in this case, the dark energy that is pushing the universe apart. Okay, and here you see how the particle comes into existence. It's just a localized special vibration of the field That whole thing is the field, right? And they're going to have this particle pop in there from the vibration of the field, local vibration of the field. That's how they visualize these particles. You know, what is a particle? It's a vibration of the field. That's what they're saying, localized vibration of a field. And but then they have to do something with it. They can't just leave it with the field. And so what do? Well, they have to show that this thing somehow interacts with one particle interacts with another. How do they do it? Because if they're separated, if they're isolated, how does one particle, interface or interact, with another? That's when they're far apart. They're isolated. Turns out that the way they visualize it, it's not isolated completely. And so here we see how an exchange of energy occurs according to general relativity. Here it goes. You can see the particle there, right? And now you have this field, another particle. You have all these quantum fields there, right? And then they have this exchange of energy. And they exchange energy, simply by the way it is, okay? And so this is the problem with all these people. Let me show you that again. Here it is. You can see the particle, and then you have all these fields. They intervene. And what it is, a bunch of fields, which is this space-time, this dark energy or unparticle, whatever you want to call it. And then it turns into these particles, simply a local vibration. Then you have the particle, and then you have the exchange of energy through the field, through the space-time. Okay? That's how they do it. So they have this nonsense in their head because they're talking about number lines, which they're shaking, and they're saying it's through the number line that that particles are communicating with each other. Okay, and so that's the state of science. Okay, or you can call it science. Okay, what do we say? Well, you need to identify the objects. You need to identify the objects. So you don't know, you can't see it or you can't touch it. There's something there. They call it a field, they call it energy, whatever they call it, time, doesn't matter, force. Okay, so you have something in there that you don't understand because you haven't seen it, you haven't touched it. And you cannot run an experiment on that which is invisible and intangible. And so this is what these people think they're looking at. They're looking at discrete particle, and they say, oh, these are discrete rabbits. They're jumping around from one place to another. And you say, okay, how do you know they're rabbits? Well, what else can it be? That's more or less the answer you get. And it turns out that, there are different ideas out there, and here's one, okay? It could be a snake, maybe or a worm that's twirling in place. Okay, maybe nothing is moving from A to B. So what they think are jumping rabbits is maybe a worm that is twirling in place. And so they haven't considered that ever, especially for the force of pull. And then the other issue is, they have these, so you do need to identify the object in order to be able to do your math. Because if you're doing math on rabbits and it turns out what you're really staring at without knowing, that invisible, intangible thing that you're looking at or thinking about is really a worm, a torquing worm, then your math is all screwed up. You're doing math on stuff that is not out there, okay? But then you have the issue of field. They have this field, and then a localized vibration of the field becomes a particle. But you got to tell me what the field is. Don't tell me that a particle is the vibration of a field. Okay, then we got to forget about the word particle and let's look at the field. What is a field? And a field is a bunch of numbers. That's all it is. And then you have, like between two magnets, right? There's some object or some thingy that we can't see or touch. And they call it a field. They say it's a magnetic field that's in there. Okay, no problem. Call it a field. I don't care. Show me the field. What does it look like? And they say, well, we can't because it's infinite. It extends to the edge of space-time, and space-time is pushing up against nothingness. You include space in there, but they're pushing against space, I guess, on the outside. I don't know. They have to tell me. But they've never identified the things, the objects. And that's why Mr. Bias cannot tell you, he not give you explanations. And he says he can answer the why questions. Of course not, because he's not doing physics, he's doing mathematics. That's why he can't. And so he thinks that equations are physics. And so here, I showed this the other day, but let's show it one more time. Okay, and here it goes. You have this fellow jumping with a rope, and the object is the rope. The region we're scanning is known as a field. And so we cannot confuse the rope with a field. Okay? The object is the rope. Okay? And the region is known as a field. And so they can't say a field does this or that a particle is the vibration of a field. That's irrational language because field is a concept, some mathematical concept. And you cannot say that, oh, it's because the field is vibrating that creates a particle and I'm going to use the particle now. Now you can't use the particle because you still haven't identified what a field is, and a field is not a thing. Field is a region of values. That's all it is. And so you have to identify the thing that is creating that region, the thing that's moving in that region. And that's what they've never done, okay? And so, so again, when they talk about dark energy or unparticles or any of those terms that they invented and they introduced in their dissertation, they're not giving you any explanation of anything. They're trying to give you an explanation, but they don't have an explanation because they're really talking math. When you put them against the wall, they'll give you an answer like Bass did, and he says, well, you're asking a why question. You're asking a mechanism question, and you came to the wrong place. We here at Cambridge, we here at Harvard, we don't do those things. We do just math. And so you have to wonder whether the unparticle that they're talking about, is that a math? Because they're talking about slight mass and they're talking about the fact that it's scalar, invariant. And does that belong in physics? Or are we just talking math? And that's more or less the state of the art of physics, mathematical physics.